Working with vectors now, skill practice says that vector v extends from 0, 0 to 3, 4, and w extends from -2, 3 to -5, -1. And we want to find the magnitude of both and determine whether they're equal. And remember, they're equal if they're in the same direction and if they have the same magnitude. The magnitude of a vector is given by using the distance formula between the points, where we take the terminal point minus the initial point. I've drawn out the two different vectors, and I've labeled each point as x1, y1, x2, y2. Initial point is always x1, y1, and terminal point is always x2, y2. When we're talking about the magnitude of vector v, we are taking the distance from the origin. The x2 is 3 minus x1 of 0 squared. Y2 is 4 minus y1 of 0 squared. 3 minus 0 is 3. 3 squared is 9. 4 minus 0 is 4. 4 squared is 16. The magnitude of v is then equal to the square root of 9 plus 16, which is 25, or 5. The magnitude of w is equal to the square root of x2 is -5 minus x1 is -2 squared, plus y2 is -1 minus y1 is 3 squared. -5 minus a -2 is actually +2. And -5 plus 2 is -3 squared. -1 minus 3 is -4 squared. -3 times -3 is 9. -4 times -4 is 16. 9 plus 16 is 25, and the square root of 25 is 5. They both have the same magnitude, which is good, but they're not equal because their directions are not the same. Notice that W is heading into the third quadrant and V is going into the first quadrant. Suppose vector v has an initial point of -4, 5 and terminal point -1, 12. Find the component form of v. Component form of a vector is found with angle brackets by taking x2 minus x1, comma y2 minus y1. x2 is always the terminal point value x, and x1 is always the initial point value of x. We then have -1 minus -4. y2 is the terminal y value. y1 is the initial y value. So we have 12 minus 5, which means that vector v in component form is -1 minus a -4, or -1 plus 4, which is 3, and 12 minus 5, which is 7. So that's angle brackets 3, 7. Component form of 3, 7 tells me then that from the origin, my vector would be to the right 3 and up 7. I'm wondering what happens if I shift it back 2 and down 4. If the initial point is now -2, -4, I can then use the component form to help us find the terminal point. I take -2 plus the x component and -4 plus the y component, which is 1, 3. That would be the new terminal point. I'm given two vectors in component form, and I want to find their sum and difference. If we have vectors defined as a1, b1 in component form for vector v, and a2, b2 in component form for vector w, then their sum is given by adding components a1 and a2 and adding components b1 and b2. And their difference is found by subtracting component a1 minus a2 and b1 minus b2, where whichever point is first has their components first. For the first problem, we have r plus s. So I'm going to call a1 and b1 the components of r, and a2 and b2 the components of s. I'm going to add negative 3 plus 12, those are the a components, and 10 plus negative 7, those are the b components. Negative 3 plus 12 is 9, and 10 plus negative 7 is 3. So the sum of vector r and s is equal to component form 9, 3. The difference has s first, which means I'm actually going to reorder because s needs to be the first component. So that's going to be a1 and b1 now, and a2 and b2 here. I have 12 minus negative 3 and negative 7 minus 10. 12 minus negative 3 is 15 because it becomes 12 plus 3. And negative 7 minus 10 is negative 17. S minus R is 15, negative 17 in component form. We're given two vectors in component form, and we want to find some scalar multiples and sums. So what I'm going to do for the first part is I'm just going to multiply each of the components by the coefficient. It's a property of vectors that says whenever you have a scalar times the vector, that vector is just the number of the scalar times the vector. Remember that whenever you have a scalar times a vector, that's just equal to the scalar value times each component. That's given that vector v is a1, b1. So for question part A, we have 6 times 11 and 6 times negative 7, which is 66 and negative 42 in component form. Part B, we need to take negative 3 times A and add that to 10 times B. So I'm going to do the scalar first and then add the components. You can write it like negative 3 times component 11, negative 7, plus 10 times component form negative 4, negative 6, which is negative 3 times 11 and negative 3 times negative 7, plus 10 times negative 4 and 10 times negative 6, or negative 33, positive 21, plus negative 40, negative 60. And then you combine their a components when you're adding. Negative 33 plus negative 40 is negative 73, and 21 plus negative 40 is negative 39. We want to find the unit vector in the direction of vector v equals 5, negative 1. First, I need to find the magnitude because remember, a unit vector is equal to 1 over the magnitude of that vector times the vector. The magnitude of vector v is given by taking the square root of, since this is component form already, I'm taking a squared plus b squared. Five squared is 25. Negative 1 squared is negative 1 times negative 1, which is positive 1. Therefore, the magnitude is the square root of 26. And then the unit vector, which is right now 1 over the square root of 26 times vector v, or 1 over the square root of 26 times ab, which looks like scalar multiplication, which we can write as a over the square root of 26, b over the square root of 26. So we're going to take 1 over the square root of 26 times 5, negative 1, or 5 over the square root of 26 times negative 1 over the square root of 26, which we rationalize by multiplying by root 26 over root 26 for each of these, We have 5 square root 26. The square root of 26 times the square root of 26 is the square root of 26 squared, or just 26 itself. We have negative square root 26 in the numerator over 26 here.